Again. Welcome back. This is going to be knowledge clip 2. The first knowledge clip, I can share that with y'all again if you're interested, but that was over how to find literature for your literature review. But in this one, I'm going to be going over how to interpret your results section from your SPSS data. So let's just get started. Okay. Table 1, correlation matrix. So in this one, this is how it's supposed to look in the APA format. If you're curious about how to put your SPSS tables into APA format, I can also just share a link to a really easy video that helped me when I was doing this. So this correlation matrix is one that was from my group project last year. So don't take any of this data like super seriously. This is basically just specific to last year. So basically what this correlation matrix is doing is this is going to be your first table. And you can just use this for observations, looking at these correlations and seeing whether something was very significant, and also noting if something was or was not surprising. Like, for example, if we look at neuroticism and maybe look at some of those correlations or openness to experience, like some of these, they have 2 stars, which means that it's very significant. The p-value is less than 0.01, which means it's very significant. There's only a 1% chance, essentially, of our findings being incorrect. So that is a really high significance. So you can kind of maybe talk about some of those, like what some of the observations. You can even say like, oh, well, neuroticism had maybe some negative correlations. You can look at gender, just anything that you would like to talk about in an observation, but you cannot use the correlation matrix to support your hypotheses. So even if you see that extroversion is related to, has a positive relationship with job performance or something like that, you cannot use that and say, oh, well, since one of the big 5 personality traits, we found a positive correlation with job performance, that does not support your hypothesis. You cannot use the correlations to actually show that extroversion actually is like accounting for the job performance measures. So just use the correlation matrix just for your basic observations and for descriptive statistics. Then moving on to table 2, which is your regression analysis. And so again, this is a table for mine. Yours doesn't have to look exactly the same, except for just the format, which is APA. This table, your regression analysis, this is what you can use to support your hypothesis 1A through E, which is talking about the big 5 and how it's related to job performance. So our dependent variable is the job performance score prior to intervention, because of course we cannot say that, let's say, agreeableness accounts for job performance if we look at the measures after the intervention, because then how do we know whether it was agreeableness that accounted for the outcome variable or whether it was the EI training? So that's why we use the job performance score prior to intervention. And again, you can only support your alternative hypotheses, which are your H1 through E, or you can reject your null hypothesis, which is basically similar to saying that you find support for your other ones, or you can not reject your null hypothesis. And the null hypothesis in this case is saying that either agreeableness does not have an effect on job performance, conscientiousness does not have an effect on job performance. Basically, there's no relationship. And so that's the only 2 ways that you should be writing your results section, is saying, well, conscientiousness, we see that it's significant. So by that case, we can conclude, we can support I forget which letter it is in hypothesis 1, but you say that you find support for that hypothesis given a significance level of less than 0.05 for your p-value. Any of the ones that have the star on it, it just means that those are significant because the probability that the null hypothesis is true is less than 5%. So it's pretty likely that we can support our alternative hypothesis. And again, never ever say that you can 100% confirm that your hypothesis is true. So you cannot say in your paper, oh, well, we found this was significant, so therefore we know for a fact that extroversion causes or is a deciding factor in our outcome variable, which is job performance. Like, you can never ever say that because this is just a sample of your population. You can never really 100% say that one thing causes or is related to another thing, unless you had a population of infinity, and then you could actually say for 100% certainty. But we can never do that, so therefore never ever state in your results section or in your discussion that you can 100% prove that these predictor variables significantly affect the outcome variable. And then just a quick analysis of the table. So this first column right here that just says B, that is your unstandardized beta coefficient. So these they kind of represent like a slope essentially. So like each of them are kind of, they basically represent slopes. And so as you see with neuroticism, it's negative, which makes sense because usually neuroticism and job performance we would expect to be basically opposite. And so you can look at these unstandardized beta coefficients to see these are not in the similar units. So you cannot compare them to each other because they're not in the same units. While this beta at the very last column, those are standardized beta coefficients. Therefore, you can actually compare those to each other because we're using a common unit of standard deviations. So therefore, if we say that by 1 unit of conscientiousness, then our outcome variable, which is job performance, is going to increase by 0.444 standard deviations. So in this case, you can actually compare all of your standardized betas, all of your predictor variables to each other because it's been standardized. And it also shows the effect, the strength of the effect, and think of it as absolute. So even though neuroticism is negative, it's talking about the absolute effect of the predictor variable on the outcome variable. So in this case, the one with the strongest effect, as we can see, is 0.444, which is conscientiousness, and it's significant. So we can basically say we find support that conscientiousness has a significant effect on our outcome variable and has the strongest significant effect. And then agreeableness is not significant, so in that case, we would not reject our null hypothesis because we do not find support. And then last thing to note is your R squared. So your R squared is talking about basically how much of the variability in your outcome variable you can account for given your model, which is your predictor variables. So in this case, our R squared is 0.647, which means that 64.7% of the variability in our outcome variable or in job performance is because or can be accounted for by our model of these 5 predictor variables. So therefore we can say that given this model and given these 5 predictor variables, we can account for almost 65% of the variability in all of the outcome or in the results of job performance. So that's another thing to note for what the R squared is actually showing you. And then the middle column is just your standard error of your beta coefficient, but I wouldn't really go into that one too much in your results section. It's not as important. And then lastly is your table 3, which is your ANCOVA, and you can use this to support or not support your hypothesis 2, which is talking about the EI training. So in this case, you have your corrected model, intercept, pretest, condition error. So this is how mine looked like. And again, keep the format the same and look at the p-values for significance. So as we can see here, all of the p-values are significant because all of them are less than 0.05. But one thing to note is that ANCOVA splits the outcome variable variance into effect, error, and the covariate. So it's the main effect of what you're actually looking at. In this case, we want to look at the main effect of the EI training, any error or any of the variability that we can't explain in the outcome variable, and the covariate, which is basically, there are some times that we're mainly interested in seeing how the EI training impacted our outcome variable. But in real life, we also have covariates, meaning there's also things that could affect the outcome variable. And so we need to basically account for those, and that's what ANCOVA does. And again, to note, the dependent variable in this case is job performance score after the intervention, because that's what we're looking at to see whether the EI training had a significant effect on job performance after the intervention. So those are the main things that you should be looking at for this table, just the p-values. Make sure to note your dependent variable, and in your analysis, basically it depends on what your table shows, but yeah, that's what I would mainly be looking at for table 3, which is ANCOVA, to support or not support your hypothesis 2. So yeah, that's going to conclude this knowledge clip. If you have any questions about the research project or need the link to show how to change your tables into APA format, then feel free to message me. But yeah, I hope you found this helpful. Good luck with your research project, and yeah, thank you.